Okay, here's another situation. We're given some solutions, and notice we're not at standard conditions here with molarity. We are with temperature, but this is what we're going to have to deal with here. And so we have a lead electrode in its ionized solution, and then we have gold with its ionized solution. All right, so what we need to do here is we need to figure out, let's just write some equations. Generally, when it's giving this from left to right, it's going to tell you what's oxidized and what's reduced. But let's just kind of write out these equations. And notice this is going to be lead plus 2 because nitrate's minus 1. So gold will be plus 3. Just making sure you get that. Okay, so it's going to be lead 2 and 2 electrons. And here, let's just look at gold. Gold plus 3 and 3 electrons. And yes, I realize I'm writing both of these as loss. But what we can do here is we can look, because it wants to know the voltage. And so we're going to want a spontaneous voltage. So let's look at lead. And there it is. Lead is negative 0.13. And gold is way up here somewhere. There we go. Positive 1.5. All right, so gold, you can tell, really wants the electrons. So this is positive 1.5 volts. So this wants to receive electrons. This wants to give them away. So this would be the oxidation. This would be the reduction. Oxidation occurs at the anode. Reduction occurs at the cathode. So that's just another way of figuring that out. So cathode, positive 1.50 minus the anode is going to give us a positive 1.63 volts. Okay, so this would be at standard conditions. We've done this before, but we're not at standard conditions. So we're going to do the same thing we did up here. And what we need to do, oh, I didn't leave us enough space. But all right, so this is going to be a reduction, so I need to write this the other way. All right, now note here that we don't have an equivalent number of electrons, so we'll need to multiply. So the net effect, what we need to know from here, no, we're gonna need our overall equation. So I'm just gonna have to write it down here. I should have given myself more space. Okay, so we have lead plus, oh, this is 3, this is 2, 6 electrons. Gives us 3 lead 2s. 6 electrons plus 2 solid golds. Now remember, so when we're doing this, we need to write our equilibrium expression. So this is very similar. So we write our equation. Now we need to write our expression for K, or in this case it's Q, because we're not at standard conditions. The solids don't really count. The electrons are going to cancel out. So we're going to have our lead. And this is why you have to do this, because you got to get your coefficients and your exponents correct. And we need to square that. Okay, after that, it's really just a plug and chug. So E is going to equal, you can still see where I've got this up here, so I'm just going to go ahead and plug it in. So 1.63 volts minus 0.0592 over 6, because that's how many moles of electrons, log in Q. So now concentration of lead ions, 1.5 we need to cube that, divided by 0.75, and we need to square that. Okay, just let the calculator do the hard work. So I'm gonna start over here and kind of work right to left. 1.5 cubed divided by 0.75 squared. Let's take the log of that times 0.0592 divided by 6. All right, so that's all of this. So now let's take 1.63, subtract. 1.62. Wow, that's really close. So we did all that work for 1/10 of a volt difference.